All right, we're now going to move on to our third and final method for solving systems of equations, and that is called solving systems by elimination. So what we're going to find in this section is we're going to solve systems by adding or subtracting to eliminate a variable. So we need to think about what that word eliminate means. And also adding and subtracting the equations in a system does create a new third equation, and where the solution to that equation matches up with the previous system is going to be something where we're going to notice a correlation there. We're going to notice something that happens. But first, let's just do a little intro with these notice and wonder with the hanger diagrams here. What do you notice? What do you wonder? So at this point, you can look at those three, and if you're listening to this video, maybe you'll pause it right now and just think about what you notice and what you wonder. So go ahead and pause. All right, so let's take a look at what we are noticing here. And so I'll just go through some of the things that I noticed when I first saw this. So basically these are scales. They kind of look like they're scales, like scale and then one side of the scale and then the other side of the scale. And I noticed that the diagrams or the scales are balanced. Let me just say I notice. So I notice that each of these diagrams are balanced. So the left side is balanced out with the right side, and it's kind of equal straight across. I wonder how much each one of those shapes would weigh then. Because we've got circles and squares and pentagons, triangles. I wonder how much each shape weighs. We'll put that in quotations. You don't really think of shapes weighing something, but these are scales, and obviously the shapes are what's on the scale, so I wonder what they weigh. All right, let's see. Well, I notice that in the first diagram, so this one up here, I notice that two red circles equals one blue square, because they're balanced in that first diagram. So I noticed that the two red circles must equal one blue square. And then in this diagram here, I notice one red circle and one green triangle equals one orange or yellow, whatever that is. I'm going to go with orangish yellow pentagon. So they remain balanced there. The red and the green shapes there balance out with the orange pentagon. Pentagon, remember, is 5 sides. All right, so in that last diagram, in this diagram, I notice that the previous two diagrams are added together to get this last diagram, right? The red, 3 red circles and a green triangle, 3 red circles and a green triangle. The blue square and the orange pentagon, and then we have the blue square and the orange pentagon. So they're added together to get the third diagram. I also notice the third diagram remains balanced. Which in my mind kind of makes sense. Since the previous two were balanced and they're added together, that must mean that that third one would remain balanced as well. Okay, I wonder if some of the things that I wrote down there are things that you were thinking about as you were looking at the diagrams here. We're going to see some of those things kind of play out with numbers as we go through our examples on the next couple pages with the elimination method.